Okay, class 42 is, it looks like it's an easy question. It's actually not that easy, so I want to make sure I'm being very clear about this. Everything on Appendix E, which are the two things I've cut out here, you see at the top with the Na aqueous plus E. So this part right here that we're looking at right there, that's one I'm going to use for letter A, but I need to explain what's going on here first. Once I explain what's going on, this will become much easier, but we've got to really pay some attention to this. So if I have something written as a reduction, okay, and my arrow points like this, if the thing that I have is on the left-hand side, then what I have is something that's an oxidant, okay? That's an oxidant if it's on the left-hand side of the reduction. If it's a reduction but it's on the right-hand side, then what I have then is a reductant. Okay? Now, this is the part that gets a little strange. If I have a reductant on the right-hand side, let me move this over just a little bit more. If I have a reductant on the right-hand side, the more negative, the stronger. Okay, so that means if it's positive, it's weak. But the more negative it is, the stronger. If I have an oxidant on the left-hand side, the more positive it is, the stronger. Okay, so that means if I have something on the left-hand side and the E reduction is positive and big, as in like 2 point something or 3 point something, then it's very strong. If I have a negative, if I have an oxidant, but that should be in A, I think. But it's negative, then I have a weak oxidant. Okay, so let's see if we can figure this one out. So the first one here is Na, and the reason why I put these cutouts of Appendix E is so that I can show you exactly what it looks like. There's that. I'm going to highlight this one so I can use the pen now. So I highlight over here, and I get Na solid. This is what I'm looking for. I'm looking for Na with a solid. We notice that Na with a solid is on the right-hand side like that, and that means it's a reductant. So this would be, and notice that if it's more negative, that's stronger, and this is very negative, negative 2.71. So this would be a strong reductant. Okay, that's an A there, reductant. Strong reductant. That's what that is for A, because it's on the right-hand side and it's got a negative E reduction value. Okay, take a look at the next one. The next one then is oxygen. Notice it's not oxygen, it's ozone. So ozone is O3, and in this case, O3 is on the left-hand side. We don't have to worry about the rest of this stuff. That doesn't make a difference. The fact that we see O3 on the right-hand side means that this is an oxidant, and because it's positive, like I said before, the more positive it is, the stronger it is, so this would be considered a strong oxidant. Okay, I want you to do the same thing for C and for D to figure that out, or the rest of them in 42, which I'm not sure if there's more than C and D. I think that's it though. Okay, do that. Strong oxidant. Okay,